All right, so think about this for a second. Right now, circling our planet at unbelievable speeds, there's a huge invisible threat. And no, it's not an asteroid. It's us. Or, well, our junk. Today, we're diving into the massive problem of space debris and the one startup that looked at this mess, a mess that stumped the world's superpowers, and saw a business opportunity. Just look at this. This is a map of what's called low Earth orbit, or LEO. It's basically the neighborhood where most of our essential satellites live. You know, the ones that give us GPS, weather forecasts, and even banking services. But as you can see, it's gotten incredibly crowded. We've basically turned the final frontier into a high-speed junkyard. And yeah, there are thousands of big objects we can track, but the real danger? It's the small stuff. The U.S. Space Surveillance Network estimates there are over 100 million pieces of debris smaller than a centimeter. Every single one of them is like a tiny, untraceable bullet, just waiting to collide with a billion-dollar piece of technology. So you might be asking, how did it get this bad so fast? Well, two major events really kicked things into overdrive. In 2007, a Chinese anti-satellite test intentionally blew up one of their own satellites, creating this massive cloud of shrapnel. Then, just 2 years later, an active American satellite accidentally T-boned a dead Russian one. And just like that, these two incidents added hundreds of thousands of new projectiles to the mix. To really get your head around the danger here, you have to think about the speed. I mean, we're talking about objects moving at over 17,000 miles per hour. At those velocities, even something tiny has terrifying power. And this quote just says it all. A piece of space junk the size of a cherry hits with the force of an exploding grenade. Now picture millions of those flying around. And here's where it gets really scary. The problem actually feeds on itself. This was a theory proposed by NASA scientist Donald Kessler way back in 1978. It all starts with one collision, which doesn't just take out two objects. No, it shatters them into thousands of smaller pieces, and every single one of those new fragments becomes another potential bullet, which, you guessed it, dramatically increases the chances of even more collisions. And this chain reaction just keeps going, like a set of dominoes in orbit, until low Earth orbit becomes a completely impassable minefield. It would trap us on our own planet and destroy the satellite networks we rely on for modern life. That nightmare scenario, that's the Kessler syndrome. And a lot of experts warn it's not just a theory anymore. It might have already started. So if everybody knows this is a ticking time bomb, why in the world has nobody cleaned it up? Well, the answer is a classic, frustrating economic problem. It's called the tragedy of the commons. Think of it like this. Space is a shared resource, like a public park. Everyone gets to use it, but nobody actually owns it. So every country has a huge incentive to launch their own satellites for their own benefit, but almost no incentive to pay to clean up a mess that affects absolutely everyone. And what's really wild is that our usual fixes for this kind of problem are totally useless in space. One solution depends on clear property rights, right? But you can't own space. The Outer Space Treaty says so. The other solution relies on community rules and enforcement. But, there's no global space cop to hand out tickets or force nations to play nice. And all of this leads to what you could call the Great Space Gridlock. For decades, any real progress has been completely frozen in this four-way stalemate between technology, law, money, and geopolitics. Let's break down those barriers. Technologically, trying to catch an object that's tumbling and spinning at 17,000 miles per hour, it's an absolute nightmare. Geopolitically, the same robot that can grab a piece of junk can also grab an enemy's spy satellite. Financially, nobody can agree on who should foot the bill. And legally, you can't touch someone else's space junk without their permission, and nobody wants to raise their hand and accept the blame. This quote from Marshall Kaplan just hits the nail on the head. It perfectly captures the paradox. Everyone agrees this is a huge, growing problem, a growth industry even. But because of that gridlock, there's literally no one willing to pay for a solution. But this is where the story takes a turn. Because where governments and giant space agencies saw an impossible problem, one man saw the business opportunity of a lifetime. This is Nobu Okada. When he was just a teenager at NASA Space Camp, he met Japan's first astronaut, Mamori Mori, who wrote him this note. And that message planted a seed, even as Okada went off and built a totally different, successful career in IT. So after making his fortune, Okada hit what he calls his midlife crisis. He remembered that childhood dream and started going to space conferences. And that's where he became completely obsessed with this debris problem. and totally baffled by the fact that no one was doing anything about it. Then, at a conference in 2013, he had his light bulb moment. He's listening to all these experts argue in circles about whether the tech, the money, or the laws should come first. And as he put it, he realized their gridlock wasn't a problem. It was an opening. It was the perfect opportunity for an outsider, for a fast-moving startup. So in 2013, he founded Astroscale. So what was the big plan? How was Astroscale going to break a stalemate that had frustrated world superpowers for decades? Well, it was with a surprisingly simple and kind of sticky idea. Okay, so on the left, you see the old way of thinking. These are the complex, super expensive ideas from big space agencies. Things like giant nets, harpoons, and robotic arms. But Okada saw all that complexity as the problem. His idea was radically simple: a spacecraft with a flat, sticky plate. The plan? Get close, stick to the debris like cosmic flypaper, and then just nudge it back into the atmosphere to burn up. Simple. But Okada's true genius wasn't just the tech. It was his business plan. This was how he was going to solve the tragedy of the commons. Step 1, build the simple, cheap tech. But step 2, this was the masterstroke: find the first customer. He looked at the new mega constellations from companies like OneWeb and SpaceX and realized their multi-billion-dollar networks were incredibly vulnerable. For them, a dead satellite wasn't just junk. It was a direct threat to their business. And boom, you have a paying customer. Step 3, once you prove the tech works, it puts huge pressure on governments to finally create new rules. And step 4, Astroscale is now sitting pretty, ready to dominate a brand new market that it literally willed into existence. And they moved at startup speed, not government speed. Okada laid out this incredibly aggressive timeline he called the 7-year marathon. The whole goal was to go from just an idea in 2013 to a full-on demonstration in space by 2020. I mean, that's a timeline that's basically unheard of in the traditional space industry. But here's the most disruptive part of all: the cost. Look at this. Other proposed debris removal missions were estimated to cost hundreds of millions of dollars. Astroscale's goal was to do it for 1/10 of that. For the first time, cleaning up space wasn't just theoretically possible. It was actually economically viable. It changed the whole game. Okada knew exactly what he was up against, and this quote from him sums it up perfectly. That gridlock of tech, politics, and money was a massive rock. His tiny startup, it was just a small wedge. But you know, sometimes a small wedge, if you put it in exactly the right place, is all you need to crack the whole thing open. And that's the question that leaves us with. Astroscale is betting everything that a smart business model and some clever, disruptive tech can actually succeed where decades of international policy have completely failed. The entire future of how we use space might just depend on whether or not they're right.